In this video we're going to have a look at Dawlish Warren, take a e-field trip if you like. First thing I've got to do is work out which way north is on my sketch map here. It's a Google Earth image, we've got north, maybe you worked it out yet. It's a set square to help you out. You could look at this line here, the front of the spit, compare it to the front of the spit there. Pick 2 points, like this feature down here, that's this feature here, and the end of the spit. Kind of draw a line in your mind. Okay, got it? Excellent. So, field trip to Dawlish Warren, I'm going to use GIS to investigate the case study. This is where we're going to start, and this is kind of where the modern story of Dawlish Warren begins. Here, we've got a railway line. Railway line put in the end of the 19th century. Because of that railway line and the need to defend that railway line, Dawlish Warren Spit has changed. That's kind of the center of this story, so you have to remember that. What we have here is Langston Rock, which is a fairly hard, red, sedimentary outcrop, and that acts as a sort of natural groin sticking out into the sea, and it's trapped this beach here. But this railway line is a big investment, and so it needed to be defended even more. And so here we have this groin sticking out here too. This side now we've got this beach accumulating. You can kind of see from the colour that when the tide comes in, most of this will get flooded. But this beach is accumulated, so longshore drift must be travelling in this direction along the coast and building sand up against this groin. But over here, well, we don't have much sand, do we? This is exposed rock, a rocky platform. Now if we have a look at the GIS, this is Google Earth image. I can just put north in the same direction as it is on the sketch map there. So we're in, if I scroll all the way out, you can see here we are in the southwest of England. If you need to find it yourself, it's the X River. And here's Dawlish Warren. Well, we're starting over here, Langston Rock. And as you can see, here we've got the sand building up here, but then we don't seem to have the sand here. One thing we're going to do, or one thing we can do, is measure the length of it. So if I decide to start at Langston Rock, I want to measure the distance all the way out to the end here. Just drag that into picture here. 2.9 kilometers. One thing I can do with Google Earth is if I click on the timer here, I can now go back in time to see what's happened to it. So here we are in 2014. Here we are in 2010. I wonder what the distance was in 2010. Well, I can check it out, can't I? Again, go from Langston Rock out to the end of the spit. 2.872. It's a fairly minor change. Could be to do with my measurements or to the tide, because parts of this will be flooded and exposed at different times. We go back further, here we are in 2003. .7. So it would seem that the spit is getting longer. Another thing we could be measuring is the distance across its narrowest point. I'm going to scroll in further. I measure the distance just to the back of the beach here. That's 45, almost 46 meters. If I then take it all the way back to 2014, we've got 25 meters, 26 meters. So this area here seems to be really quite vulnerable at the moment. the spit would seem to be becoming more elongated but thinner. If we look at the next stage in the story of the spit then. So moving on down, here we've got the train going along. Here, well, that's a seawall, isn't it? There's a promenade on top of it. You see the steps going up. A bunch of geography students here measuring things, like geography students are supposed to. The beach here has been built out partly due to limestone rock, partly due to that extra groin I mentioned earlier. Here we are looking in the other direction. On the sea wall here, then we've got the natural beach up against limestone rock, and then we've got groin there, and under here we've got all the sand that's been trapped by the groin. You can notice here at limestone rock, it all obviously seems to be falling apart because we've got some rocks about the floor here in the sand, which may well have fallen from there. We've got cave and arch features which show that there is some erosion going on, and all the people are wearing little yellow vests. So that must mean that it's falling apart too. We can see here as well they've walled up the back of the arch. They've done that because they don't want the sand escaping through that natural arch, so they've turned limestone rock into a piece of groin. And then we've got this high seawall, you can see, groin. You can see there is not a wooden one, this looks like concrete or brick, and it's there to keep the sand in place and protect that railway line. Here's the Red Rock Cafe. If we have a look at our GIS image again, we'll see if we can find that one. Zoom in here. It's somewhere on limestone rock, but I don't know where. What I could do, if I can't find something and I want a photo of it, say, I could turn this layer on, or overlay on top of my map image, photos that people have taken and uploaded in place. Red Rock Arch. Can I find one that says Red Rock Cafe? That would be kind of useful. Someone's favourite place for a cup of tea. There we go, that's the Red Rock Cafe. So that's where we are then. Just behind the second of these two big red rocks. This shows that this area obviously has some kind of tourist function. Behind it we can see a line of riprap as well. If we move on down, we can see here now I'm standing on the groin, taking a photo towards limestone rock. I didn't take any of these photos, by the way. We're standing on the groin, taking a photo towards limestone rock. We've got sand and sediment building up on this side. This side's noticeably lower. So the sediment's building up on the updrift side, and the downdrift side is sediment starved, and that's causing this area to be more rapidly eroded. It's called terminal groin syndrome. So there's no groins holding this beach in place, and the sediment is not getting there because it's being held behind this groin, and so this area is sediment starved, suffers the most erosion. That's terminal groin syndrome. Moving along, here we are, we're up in the dunes and we're looking down onto an area of car parking here. If you're annotating it on a copy of this, you're annotating it on a copy there, we'll just find out where that is. So I'll pull my GIS image over again. I've moved along. Can I find a car? Yeah, there's a car park right there. But apparently there's new beach outside, or nearby it too. Or at least they were new in 2008. So this is Dawlish Warren Car Park. No idea why someone would take a photo of that on their holiday, but it's fortunate for us that they did. We can also see some tourist facilities down here. And so that picture must have been taken from up here somewhere. Right. This is a diagram showing what has happened really to Dawlish Warren. Here, this is where longshore drift used to carry material. This is where there used to be a spit. This one migrated into that one. It created a little lake or pond in the middle, which has then later been filled in. This whole area has been now eroded. There are some sandbanks that are exposed at low tide, but the warren itself is being eroded and moved back and made thinner, which is a big concern. It's a big concern because if we go back to our GIS image and try and take a larger scale view of what the value of this warren is to Dawlish warren is to people, well, there are people who live up here. We've got a settlement. We've got where these little specks are. This is the place where people are keeping their boats. If I zoom back out, here I've obviously got a relatively large settlement, and another one here. All of these areas, Exeter, Exmouth and Dawlish itself, receive some level of protection from Dawlish warren. It is a natural sea defence that defends the estuary of the Exe. So if we get this broken, if this all got eroded, there'd be an environmental impact on the warren itself, on the marshlands behind it. There'd also be an economic impact. These people's houses would be more prone to flooding. I'll continue this in a separate video.